Hello, my name is Dr. Ibrahimian, and in this channel I go over problem-solving strategies primarily in math competitions. In this video, I'm going to go over problem B2 from Putnam 2014. Suppose f is a function on the interval 1 to 3 such that f of x is between -1 and 1, and we have integral of f of x from 1 to 3 is 0. How large can this integral be? Well, the first thing that I thought is maybe I need to use Cauchy-Schwarz inequality. So if you take f of x over x dx from 1 to 3, we can say this squared is less than or equal to integral from 1 to 3 f of x squared dx, and then integral from 1 to 3 1 over x squared. Unfortunately, this was not very promising. You can replace this by 1, and you can say this is less than or equal to 2. That's the integral from 1 to 3 of 1, and then integral 1 over x squared dx 1 to 3. You can then evaluate this one, but this equality cannot hold, because in order for the equality to hold, you need f of x to be c over x, which means f of x cannot be just plus or minus 1. So this is not going to work. But then I realized that I have some portion of f that is positive and I have some portion of f that is negative. I would like to put the portion that is positive over smaller denominators and the portion that is negative over larger denominators. In that case, this is going to be the largest possible. Let me graph this one. So the function f between 1 and 3 has integral 0, and I want to maximize the integral from 1 to 3 f of x over x dx. Well, the largest possible value of the function is 1, and the smallest possible value of the function is -1. So which part should be positive? The part that is close to 1 would have to be positive, and the part that is close to 3 would have to be negative. And because I want the integral to be 0 from 1 to 3, I would have to cut this in half. Probably this would give me the largest possible value. In other words, I'm going to take the integral from 1 to 2 of 1 over x dx, and then plus integral from 2 to 3 -1 over x dx. The first one is natural log of 2. The next one is negative natural log of 3 plus natural log of 2. So I get natural log of 4 over 3. So my guess was this would be the answer. So what am I trying to prove now? If I take the integral from 1 to 3 of f of x over x dx, I'm trying to prove this is less than or equal to integral from 1 to 2 of 1 over x dx plus, or rather minus, integral from 2 to 3 of 1 over x dx. So let's see if I can do that. I'm going to take the right hand side to the left side and see what I get. So I have integral from 1 to 2 f of x minus 1 over x dx plus integral from 2 to 3 f of x plus 1 over x dx. If I can prove this one, then I'm done with the problem because I already found a function that satisfies the equality. Well, this portion is definitely less than or equal to 0 because f of x is between 1 and -1, and this portion is greater than or equal to 0. So when is this maximized? Well, if the denominator is 2, if the denominator is as large as possible, the negative number is going to be maximized. So that's f of x minus 1 from 1 to 2 dx. If the denominator of the second one, which is positive, is minimized, you get the maximum of that. So that's f of x plus 1 over 2 from 2 to 3. Let's now add these two and see what we get. So we can factor 1/2. We get integral from 1 to 3 f of x dx. And the other portion is -1 and then +1. They told us that the integral of f of x is 0, so this whole thing becomes 0. So what does that tell us? It tells us that the integral from 1 to 3 of f of x over x dx is always less than or equal to natural log of 4/3. And we found a function that satisfies the equality. So that means the answer is natural log of 4/3. That brings me to the end of this video. I will see you in the next video.